Ted Selker, an IBM fellow, directs the User System Ergonomics Research Group, or simply USER, here at the Almaden Research Center. Ted has become known as IBM's Think Man, and we were able to talk to him about his group and the projects he's currently working on. So hi Ted, why don't you tell us a little bit about your organization?
Well, I've always been interested in understanding how to make better tools for people. I don't know exactly why, but it's gotten more as I've gotten older that I've understood that really the problem is making a relationship between the task a person's trying to do and what skills they have. And so in my group, that ranges all the way from trying to understand the physiological problems that people have trying to interact with things and modeling not only those kind of static things that are time immemorial of how the physiology of us is made, but all the way to trying to model the little bits that people learn, the experience they have, and how to make the relationship between the computer and the person better by building an adaptive user model in the time that a person's working with the computer. To make that more concrete, probably I should tell you a little bit about some of the work that we're doing in these areas. We're working in cognitive, graphical, and physical interface. Cognitive interface is thought of these days kind of as agents, and I've been working on that kind of stuff for a good, I don't know, too long. But anyway, the thing that I'm probably best known for there is really stuff that came out of my PhD work. In that work, I was trying to prove to myself that you could make a system that would learn and reason in real time and actually be able to help somebody. So the point is that a person's trying to do something with the computer, and the computer deciding, well, is there any way that I can help the person? And it notices whether the person's done this before, whether they've done things similar to it, and decides how much help to give in what situation. This might seem a little abstract. In fact, in Warp 4, what we're doing is that when there's a complicated user interface, what we'll do is we'll kind of highlight the parts that you need to do, even if you're a novice, to get through, for example, installing a printer. And then we'll put some text in a bubble above this dialog box. And as a person gets better, this mask, if you will, this gauze that's over the interface will remove itself, and different things, more sophisticated things, will be demonstrated to the user. The person can use the whole interface at any point, but we're just guiding them through it and then watching their reactions. Do they succeed? Do they not? And deciding how to change the help based on that. So that's kind of at the agent end, where you have an adaptive user model that is helping a user. Another kind of agent that we're working on is is in the web. Again, we are watching a stream of information that passes back and forth between the person and an HTTP stream, so that a person is at a web page, and we have this architecture we call WBI, or Webby, IBM upside down, of course. It sits there and it watches what the person's doing, builds a model of what pages they've gone to, where they go from where, and also what's going on the web that's useful to them. So it puts what we call street lights on the links, saying, hey, it's fast to go on this link somewhere. We could put other things on those links too. What's the value of this information? What are you going to use it for? And in that way, we're able to change the user experience on the web by knowing a little bit about what the user is going to need and adding to the web pages and adding to what is recorded about the person for them to find in the automatic hot list that it creates later on how to get back to where they've been.
So this is value to the user.
This is always value to the user.
Right.
We're always trying to reduce the amount of attention a person has to pay to accomplish their goals in their tasks. So that's kind of this agent area. We do some searching, some browsing, some other things in that agent area. But we also are known, of course, for this this pointing device, this track pointing device that's made into a couple of million keyboards a year. And this thing was kind of a lot of work, and it kind of exemplifies one of the things I like to do, which is to think about the whole problem integrated from the person to the mechanics. In fact, I and we, people in my group, have patents on on several different sensor technologies even for making these things. The real interesting thing about TrackPoint, which I think is kind of the, again, exemplifies the way I like to do things, is that in order to make this thing work, not only did we have to find where to put it in the keyboard, but the most important part that turned out to be the hardest part was understanding what are the problems with a joystick that may have made it for years and years thought of as a bad device for doing cursor selection. By understanding what to do to make the shakiness and the eye tracking problems and the starting up and stopping kind of problems improved, we put stuff into the microcode that makes this pointing device actually the best pointing device in the world in terms of a person's ability to mixed typing and selection activities together. We even have, well, we have all sorts of wonderful data about how you can improve things with pointing.
That's really good. I see everybody using TrackPoints. What's coming in TrackPoint?
Oh, TrackPoint is continuously changing. People say, oh, isn't TrackPoint done? And I'll tell you a couple of things that we're excited about that are coming in TrackPoint. I don't know, maybe in the next year. And then I'll tell you about some things that we don't understand. We're making a TrackPoint that has no buttons. This particular TrackPoint, you can just press on it to make it select. You can press and drag to make it select something and move it around. And this press to select function, again, as with the first TrackPoint, I worked on really hard with Joe Rutledge. Joe Rutledge did most of the detailed work of making that work. And then we have two-handed pointing. And
that'll be built right into the keyboard. It won't look anything different.
That's right. It'll look just like this.
Yeah.
And you'll be able to press on it. You'll be able to use the button still, but it'll have this added functionality. In other words, using gestures on the TrackPoint to add function. We could actually do other things besides the pointing functions as gestures. But let's move on to the other technology that's coming with TrackPoint, which is this internet. Now people are very concerned about how do I look through a bunch of material and select it at the same time. We've got a lot of different ways of using two pointing devices together. Typically we put them in a keyboard like this, so that your hands never touch it while they're typing, and your thumb never touches it while the thumb is moving. And so you have two pointing devices. And for years I've been kind of trying to get people excited about this. Now we have some very good software that allows a person to point at tools with one hand and then select items with the other one. So they're handing things to their dominant hand. This is the way people work. People usually set up a problem with their non-dominant hand and then do it with their dominant hand. So another one is scrolling through something and selecting with the other hand. So we're doing all sorts of two-handed things. Just to give you a feeling, not that we have a lot of time, just to give you a feeling of where TrackPoint is, we have been wanting and trying to make adaptive TrackPoint software for a long time, and we keep putting more understanding of what a person is like in terms of being able to point. But we're finding that experts don't do the simple go from point A to point B. They go in a very much more interesting path from point A to point B that has to do with planning. And we are analyzing now a tremendous amount of different strategies that we find experts doing that really are a rich source of understanding what the difference is between a Nintendo playing 17-year-old and a very old elderly person who has a hard time using a pen.
Mm-hmm. So how about taking TrackPoints and putting them on other types of devices?
Oh, we're putting TrackPoint is in remote controls that we're making. This is just a prototype idea of maybe you could get rid of all of those buttons in a remote control by just having one dexterous device and doing on-screen programming. We've put it in, we've worked with people in IBM Hawthorne, Russ Taylor, to put it into a laparoscopy instrument, to put it to do surgery and watch the camera move around. We've put it into a device that has been used by the ground traffic controllers to select which airplane they're going to talk to. So the TrackPoint turns out once you have something that's good at making dexterous movement of a finger translate into precise movement in a computer, I think there's a lot you can do with it besides just, if you will, speaking to the very large PC keyboard market. The track point, I didn't, well, is also kind of an example, not just the only thing that we do in this area of having physical interfaces. The track point is an example, not just the only thing that we've done in this physical interface area. We also find ourselves doing industrial design of various sorts, thinking about what would be a wearable computer and how would it work. We kind of are playing with all sorts of things. But another example of something that we've actually taken farther than that is the projection notebook that IBM sold as the 755 CV. And that computer's kind of got a lovely ability to be able to take a personal computer that you use for just working by yourself and take the display diffuser and light source off and use an overhead projector instead as a light source, so that the whole group of people that you're in can see projected on the wall what your notebook computer is showing. And in that way, without rebooting, without any extra wires or equipment, you're able to turn a personal computer into a presentation computer.
I get the feeling that your designs are constantly evolving.
Well, I'm looking at this is number 15 on it, and that's when we started counting. I had this dream of taking this. This is a commercially available IBM PC that runs Windows 95. I was so enamored with this thing and its size that I thought, wouldn't it be great if I could put this thing on my belt? And so we made this clip, and this thing can just clip on like this, and you can wear it. So the point really is that I've got a drawer full of the 30 or so clips that we tried getting to this design, and as you can see, it's not done. I find that there's never a design that is complete. You can always improve design. I mean, what about that stupid angle right there? That angle was supposed to echo that angle over there, and I think it looks just terrible at this point. So I want to get rid of it. Design can always be improved. A paperclip, somebody was asking me, well, what about a paperclip? A paperclip's a terrible thing. It slips off, it's sharp, it's metallic, you can't put it in the recycling center, and so on. So a paperclip's wonderful, but it can be improved. And I think that one of the fun things in my life is seeing the possibilities whenever I see some design, being irritated by the things about it that I could improve, and then trying to think through what would that really be like if you could, for example, with a track point, if you could not have to hold your finger down all the time while you're dragging, but put it into a locked position so that this keyboard actually lets you lock into a drag mode. That's an example of that.
So how about when things get smaller, like you showed us that little portable computer there, how do we deal with the smaller keyboards?
Well, I think that the size of our hands don't change, and the real issue for me is that computers have now gotten to the point where the size really can be dictated by the control surfaces that are necessary for people to work with computers. I've been a strong disbeliever in technology that is a high noise to signal ratio and it takes lots of computation to do, such as voice and image understanding. On the other hand, these things are actually getting to the point where they might become useful. And we're really spending some time now thinking about where would it be useful to not take your eyes off of something. In a car, maybe. How would you make the computer tell the person that their voice is being understood or not? Maybe with little ahs and ums and the kinds of things people do. And how do you make a technology, any technology, at any point, has to be placed relative to how to make a scenario that makes it fail soft. That is, you don't notice its brittlenesses. Right? And I think that as things get smaller, we have a choice. We can have fold-out things that make it so we have a big control surface, or the control surface can be the whole device, or we can change our modality. But the points of changing our modality shouldn't be because the computers got small. It should be because the scenario works with that shape form factor. It used to be that we had to sit at a roll-top desk, that we could cover the inkwell so our kids couldn't get to it, and we'd do our concentrated effort at a desk where the pieces of paper would not blow away. Now we're getting to the point where we don't have to sit in such a constrained position. Our pens have balls on them, and we don't have to worry about them leaking all the time. And now we've even able to carry around that display and not have to sit at that roll-top desk with that big monitor, but rather be able to take our notebook wherever we want to. Is it going to get, as they get smaller, are we going to be able to concentrate and focus on information with things that are this size? Are we going to be able to do the detailed, hard, focused work that we need to with this kind of thing? I think it's very exciting. I think there's a lot of things that are going to happen. And I think the issues revolve around how to make a person able to really integrate technology into their lives, to reduce the amount of effort they have to do to perform a particular the amount of effort that they have to do to perform particular tasks, and as well how to make a person able to not let the technology intrude on that on that wonderful thing that happens between people, and rather to support getting things done with other people.
Right. Well, this whole ease of use issue, the whole ease of use area is very important for IBM. How are you influencing our products?
Well, I think in a big organization that has a lot of momentum like IBM, it's always difficult to figure out how to dovetail in such a way that you really support and make products progress in the ways that they can. I think Tony Temple does that as his whole job, trying to get the whole company to integrate. I'm working with him. We have some funding to change some of our work to make it more applicable to other parts of the company, and I think that's really, really exciting. But I spend a tremendous amount of time trying to work with the ThinkPad team, enjoying understanding their constraints and working to try to invent in the areas that they find there to be possibilities. I find that some of the most exciting work I do. I work with the Aptiva group, thinking about things that maybe can be preloaded, ways to change the form a little bit and make things more ergonomic. We work with the people that write software for our operating systems, trying to think about ways to put new function into the software. We have even enjoyed trying to get graphical user interface onto ThinkPads in the preload to help set up, to make it more concrete. And we work with various people in research, and we sometimes get little relationships that come and go from other people. For example, today, somebody from the RS6000 area called me up about a big customer that has an RSI problem in some CAD workstations. And I spent 10 minutes talking about all sorts of possibilities that no one does right now in terms of getting rid of some of the fundamental things that cause RSI.
But Ted, I've seen a lot of advances in 3D user interfaces. What are you doing in that area?
I think that anything that you can do to make a user interface more concrete improves its ability to tell a person what it's about. And I think this the work in places that Dick Berry's been working on is a good example of that. The idea of making landmarks that are persistent, that stay in the user interface, that a person can expect to find something over by the store or something is helpful. For example, what we've done is we've taken the Webfinity network management software and gotten an interface that had a whole row of icons and another row of icons and turned that into a very simple looking room with a computer and a connection to the network wall and the rest of the network, posted on the wall, alarm and so on. And so using these concrete things, you can make things simpler. Another example of something we've done is we've taken all of the radio buttons in the setup screen on the ThinkPad, and we turned one of the first interfaces you see that tells you about how to set up the computer into really a picture of your ThinkPad. Why not be looking at your ThinkPad on the screen when you're hooking up the infrared or the track point or turning on a serial interface, so that you can see them and you have some tangible notion of what they are at the same time that you're doing things with them. So we're working on trying to understand how this representation can be used to present information more concretely, and to save person the effort of, one, having to look for things, and two, having to interpret them.
Great. I've heard you working on a project called Room with a View.
Oh, yeah.
What is that?
Room with a View is an idea of how to make a virtual reality that people can come into together. So instead of having to sit here and experience your own personal nirvana, you have this situation where we have a table, and the table has tablets on it, and the wall has a projection of everything that you're working with. Just like an old-fashioned office where you have all of the books that say something about you on the wall and the pictures on the wall. This Room with a View has a picture of a wall, and your peripheral vision then orients you with what folders you're going to need, what books you're going to need. There's a picture of a window. Out the window you can see something's going on out there. It looks like a world in the distance. Actually, it's the World Wide Web. You can then pick up one of these tablets off of the table, point it at the wall, and get something off of the wall. So instead of sitting in a pseudo-ergonomic position, what you get to do is you get to take this tablet that has the World Wide Web on it, put it in your lab, work with it, hand it to somebody else, let them work with it, put several of these tablets that are part of a project, a book, a reference material, the paper you're writing, lay them around on the table, each of them having a physical instantiation. It's kind of like having physical windows, as you were talking about the other day, and then be able to work with them, having a lot of the focus materials in front of you, and still not wasting the screen real estate with that orienting material that's now on the wall projected.
A lot of exciting work going on here. Thanks very much for your time. I really enjoyed it.